I know, I know. You're thinking, the last video was so great, Mr. S. Part 2, when is that coming out? Well, it's coming out near you. I'll be all week. Light on the momentum problem. Suppose you stand 10 feet away from the base of the Washington Monument. Never been there before. And shine a flashlight at it. Blah, blah, blah. Alright, so I guess you are here. You're shining a flashlight at that spot. Let x be the angle in radians. The light beam makes the horizontal line. The light beam makes a horizontal line already. The light beam. That looks slanted to me. Let y be the vertical distance in feet from the flashlight to the spot of the light. Okay, this is kind of getting me. Am I misreading this? Let x be the angle in radians. Okay. Let the light beam. Let x be the angle in radians the light beam makes with the horizontal. Oh yeah. Okay. So x is just degrees, and we get. Show that y equals 10 tangent x. Okay, that's not going to be too bad. We're going to make a right triangle. Let's go with the next one. Let's go with green. As you rotate the flashlight upwards, what rate is y increasing with respect to x? So we're going to look for dy dx when x equals 1, at x equals 1. What are the units of this rate? Ooh, and what is the rate in feet? What is the rate in feet per degree? Okay. And then the last one we're going to do is, at what rate does y change when your light points at the top of the vertical monument, where y equals 535, and then I believe that was, what's y again? In feet. Okay, 535 feet. Alrighty, let's do this problem. So you draw your little triangle, and viewer said that we are 10 feet away. This is supposed to be the height, and x is supposed to equal the angle. We don't know what the hypotenuse is, so that's none. So from SOHCAHTOA, sine, cosine, tangent, tangent is the only one that has both the opposite and the adjacent of x. So you're going to put down tangent equals y over 10, because we say SOHCAHTOA. TOA means tangent. TOA means means tangent of x. To means opposite over TOA adjacent. So that's kind of how I use the word TOA. I should have probably written it out instead of sounding silly. Then you multiply both sides by 10 to make it look like y equals 10 tangent of x. As you rotate the flashlight upwards, at what rate is y increasing with respect to x? So remember what dy dx represents? That represents y prime essentially, but another way to say it is how much y changes, the rate of change of y due to x. So let's look at dy dx. We have 10 tangent. We do know what the derivative of tangent is. It's simply secant squared of x. So 10 tangent x would be 10 secant squared of x. That's one of those things you have to remember. But they're asking when x equals 1. So plug in 1 in here, and that should give you whatever the answer is. So you end up with, and I want 3 decimals, please. 34.2255 feet per radians. Now the reason why we say radians is when you look at x, it's at x is in radians. So it's feet per radians. Remember how it's dy dx? So the change in y is in feet, and the change in x is in radians, so feet per radians. Alrighty, so that was that. Let's say you want to have it in pi. You simply let's say you want to have it in degrees. You simply do the fence method in your science class, if you remember that. So you have this, you have pretty much have this, right? And then you're gonna create like a fence. And then you see, you want to set things up so things would cancel out. You see that radians, and I'm going to use green now. If you place pi radians over 180 degrees, then you see that radians is going to cancel out radians. And with the fence method, you just have to make sure that these the conversion factor equals 1. And since pi and 180 represent the same thing, that really is 1. So multiplying 34.255 by 1 doesn't really change the number, but I will change the unit. So radians cancel, leaving you with, let me get my fancy highlighter, feet per degree. By the way, they wrote feet here again. So I guess I didn't need to highlight that. That's how you would do it. So multiply by pi over 180 using the fence method that you learned in your chemistry or physics class. The reason why the next problem is a little complicated is because we want to know what the rate is, the rate of change of y, but we don't know at what x. They only tell us that dx happens when y equals this. So not y prime, but regular y. So take your regular y equation and then plug in the 535 and solve for x. So divide both sides by 10. That way you can cancel out these 10s. You end up with this bad boy right here. Now, how do you get rid of a tangent? You do the arctangent. So the arctangent on both sides, you can use a calculator to figure out what this is. Arctangent and tangent to a -1 mean the same thing. Not the same thing as cotangent. So there's a little bit of misconception. Some people think that the cotangent is the same thing as this guy right here. It is not. This right here is just the multiplicative inverse, where this right here would be the function inverse. You know what I mean? So cotangent literally means 1 over tangent, where tangent to the -1 implies what value must go into tangent to get this. So that's pretty much the difference between the two. So those do not equal, no equal sign, none. 9! Okay, let's continue. So we find out what arctangent is. And once you have your arctangent, it goes back into the derivative function. So that seems to be the arctangent right there. You plug in, that's probably what the calculator gave you. Then you square it, multiply by 10, and you have your rate of change. And it's a large rate of change, but you are to expect it. As you go higher with the same rate at which you're changing the x, you would expect the y to change a lot quicker, given that that it's becoming steeper and steeper and steeper. You know what I mean? It's like if it probably went like, because it's a straight line, but moving the hand like the same way, because as you go up like this distance, like for instance, if this angle is the same as like these angles, you see that the distance happens to be a lot, you know. So if you're wondering why the rate of change is so much larger, it's because as you go upwards with the same angle, these y's become bigger. I digress. I'm talking about it way too much. Moving on. All right, another problem we're going to do is a point of light problem. As the beacon light at an airport rotates, the narrow light from it forms a moving point of light on objects in its path. The north-south wall of the building is 500 feet east from the beacon. Let x be the angle in radians, the light be mixed with the east-west line. Let y be the distance in feet north of this line where the light beam is shining when the angle is x. So I kind of looked at the problem already, so I think that's kind of what it looks like. Again, we are saying x is the angle in radians, and then y would be how much we're moving in the y-axis, because it's saying north of this line. And we're supposed to show that it's 500 tangent x, and given that we are starting from 500 feet east of the thing. By the way, east would be that direction. So we are again going to draw a red triangle like we did last time, so that shouldn't be a problem. Let t be the number of seconds since the beacon was pointed due east. Find the change in y after time. And x is inside the function, blah, 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 blah. By chain rule, the answer will contain dydx. Suppose that the beacon is rotating counterclockwise at 0.3 radians per second. What does dx dt equal? How fast is the point of the light moving along the wall when it passes the window located at y equals 300? It's the exact same problem. I'm kind of tempted to not do this problem. Maybe let this be a homework thing so you guys kind of work on it and show it to me. So should I stop the video? Nah, I'll just do it. Alrighty. But you're going to have another problem to work on in class anyways. So let's go ahead and do this. So to show it, you have a right triangle. You start off with the whole tangent of x equals y over 500. Multiply both sides by 500, you get 500 tangent x. Now to find the derivative, the 500 is just the same thing, right? We just leave the 500 out of this, man. And then the derivative of tangent is secant squared x. And we stop right there, because that's all they're asking for, right? Oh, they want dy dt. So here's the thing. So right now what we have is dy dx. 500 secant squared. What dy dx means is dy dx means that we took a derivative based on x, which is what we did. That's actually all we were able to do. If they want dy dt, we have to multiply dy dx by dx dt, because then you would see the x's cancel out. It makes calculus teachers mad when you explain it this way, but essentially that's what you have to do in order to get dy dt. So let's find out what, So in order to get dy dt, we clearly need to find out what dx dt is, so we can multiply dy dx by dx dt to get dy dt. Oh, fun. Who needs like video games, friends, social life, Starbucks, Frappuccinos, if you can have this? Alrighty, so dx dt, let's find out what that is. Alrighty, so I had some difficulty because I was actually looking up here to find out how much the angle is changing per second, because we're looking for the angle per second rate of change. And I couldn't find it here either, but they did say find dy dt. But then when I read the next one, I actually found it. It was set right there. Suppose that the beacon is rotating counterclockwise at 0.3 radians per second. So what I'm guessing is happening here is that was probably the final answer. You knew that you had to multiply by dx dt, so you just leave it as an open variable to be used later. And now that it actually gave us what it is, now what does dx dt equal? And that doesn't make sense, because you literally are giving it to me though. So the beacon is rotating counterclockwise, so it's rotating counterclockwise at 0.3 radians per second. What does dx dt equal? Well, it equals 0.3, right? Am I missing something over here? Like, why are you giving me the answer? Why are you giving me this answer and then asking me what it is? All right. So we finished the first question. How fast is the point of light moving along the wall when it passes the window located 300 y equals 300? So first of all, we need to find out what 300 really is, right? I mean, what x we get at 300. So go ahead and let 500 tangent equal 300. And then do what we usually do with the arctangent, what we did in the last problem. You should get this. Plug it in to, I suppose, this equation that we just created. And this time, put in the answer that they gave us to the question that they asked right after, and which is 0.3. And what you essentially find is, instead of finding dy dt, dy dx, instead of finding like feet per radians, you now found feet per second because you multiply by the 0.3. Like if you would have just done dy dx, like if we only had, imagine that was an x, right? If we only use this equation, the 500 secant squared, then you would have found feet per, y's feet and the x's radians, feet per radians. But because you multiply by dx dt, the radian differential went away and is replaced with the time. So now we have feet per second. I hope I'm making a lot of sense. I might not be making any sense. And the fact that I'm moving left and right is not really helping. But the answer is going to be, because essentially now you have dy dt, you have feet per second as your answer. So multiplying by that 0.3 made it feet per second. If you did not multiply by the 0.3, it would have been feet per radians. As a matter of fact, hey, how do you get feet per radians? Well, take your answer here and divide by 0.3. So 204 divided by 0.3 would have given you feet per radians. Alrighty, so what is it asking for again? Where am I? What is dx dt equal? Well, it's that. How fast is the point of light moving along the wall when it passes through the located at, and they don't even ask for feet per second, you know? You could have probably left it at like, you probably didn't even need to do all of this stuff, you know? Could have probably left it at 500 secant squared of 0.5404. And then you could have just said, oh, it's feet per radians. You didn't tell me per second. You didn't say nothing about unit, nothing. But I guess we just did it in case they wanted that. So 204 feet per second and 204 divided by 0.3 feet per radians. I hope that makes a lot of sense. Please ask me in class if you're still confused about this. Have a fantastic day.